So in math, we have a convention where no radicals are allowed in the denominator. And the reasoning behind this is really the same as the reasoning why we simplify fractions to their simplest form. It's so that we can compare them easily to see if they have the same value. So for example, if you have 6/9 and 8/12, just by looking at the fractions the way they are, it's very hard to tell if they are actually equivalent or not. So we would simplify both of these fractions. So for the first one, we would divide top and bottom by 3. And for the second one, we would divide top and bottom by 4. And so for the first one, you'll see that it's 2/3, and the second one is also 2/3. So now we can tell that they are actually equivalent. It's the same idea for when you're dividing by square root. If you have a radical in the denominator, it's very hard to tell if it's equivalent to another fraction with a different radical in the denominator. So we don't allow radicals in the denominator. So to get rid of, for our example, a radical 5 in the denominator here, we would multiply top and bottom by the same thing. So we would multiply by a radical 5. The reason we're multiplying by radical 5 is because radicals, for a square root at least, you need 2 in order to cancel out or to come on the outside. So because we have a square root of 5 here, we need another square root of 5 so that they become a pair and they can come outside of the radical. If it was a third root, for example, then we would need 3 in a group in order for it to come outside. But because of the square root, we only need 2. So square root of 5 times square root of 5 in the denominator, we would just have 5 left because square root and square root cancel each other out. Or you can also think about it as you have 2 5s, so together they come outside. And it's still being multiplied by the 3. And in the numerator, because we're multiplying these, we multiply the coefficients first. So 4 times the invisible 1 here. So 4 times 1 gives us 4. And then rad 2 times rad 5. And because they don't have any common factors, we can just multiply them together. So rad 2 times rad 5 gives us rad 10. And then let's simplify. So we have 4 rad 10. And then in the denominator, we have 3 times 5, which gives us 15. Now, one thing I want to note is that it is not the radical 10 and 15 that can cancel out. The reason for this is because the 10 is inside a radical. It's not a regular 10. So 10 and 15 don't cancel out. The only things that could possibly cancel out are the regular numbers with the regular numbers. So meaning the 4 and the 15. But because 4 and 15 don't have any common factors, they can't simplify. And so this would be our final answer. Okay, now what if in the denominator you have a binomial? So for example, -1 minus 2 rad 5. Well, it's not going to be enough to just multiply top and bottom by rad 5, because if you think about distributing this, rad 5 times -1 is going to give you a rad 5 back. So we're still going to have a radical in the denominator. So it's not enough just to multiply by the square root of 5. We have to multiply by what we call the conjugate. And the conjugate is basically the exact same binomial, but with the opposite operation in between. So in this case, it would be -1 plus 2 rad 5 is what we would multiply on top and bottom. So -1 plus 2 rad 5. And you'll see why after we FOIL out the denominator. So let's FOIL out the denominator. So first, -1 times -1 gives us a +1. Then the outsides, -1 times 2 rad 5 gives us a -2 rad 5. Then the insides, so -2 rad 5 times -1 gives us a +2 rad 5. And then the lasts. -2, because these are both radicals, let's focus on multiplying the coefficients first. So -2 times -2 gives us a -4. And then a rad 5 times rad 5 gives us just a regular 5. And now you'll notice why we had to multiply by the conjugate, because the outsides and the insides cancel each other out, because you have a negative rad 2 rad 5 and a positive 2 rad 5. And so because these are like terms and they're the exact same thing but opposite signs, these two cancel each other out. So in the denominator, we're not going to have any radicals left over, and that's what we're aiming for. So that's a good sign. And so let's now finish multiplying out the numerator. So again, let's multiply the binomials. So multiply the first, so -4 times -1 gives us +4. Then the outsides, the -4 times 2 rad 5 gives us -8 rad 5. Then the insides, rad 3 times -1 gives us negative rad 3. And the lasts, rad 3 times 2 rad 5 gives us a +2 rad 15. And you'll notice that in the numerator, there are no like terms, because remember, for like terms, we're looking for the same index, meaning the type of radical, so square root, cube root, and so on, and the same radicand, so what's inside the radical. And so you'll notice that they're all the same index because they're all square roots, but they have different radicands because this is square root of 5, this is square root of 3, and this is square root of 15. So none of them are like terms, so we can't combine any of those together. So in the numerator, we have the same thing. So 4 minus 8 rad 5 minus rad 3 plus 2 rad 15, and then we can simplify the denominator. Negative 4 times 5 is just negative 20. 1 minus 20 gives us negative 19. Okay, now we don't have any radicals left in the denominator, which is a really good sign. But it's also weird for us to have negatives in the denominator, so we still need to take care of that. So we would multiply top and bottom by a negative 1. And so what essentially happens is all of the signs change because a negative times a positive gives you a negative, and a negative times a negative becomes positive. So all the signs change. So the positive 4 becomes a negative 4. The negative 8 rad 5 becomes a positive 8 rad 5. The negative rad 3 becomes a positive rad 3. And the 2 rad 15 becomes a negative 2 rad 15, all over a positive 19. And again, there are no like terms to combine, and there's nothing to simplify, so that would be our final answer.